right, welcome to Chapter 1. This is going to be Section 1.1. It's on analyzing graphs of functions and circles. Just a quick reminder on how to find x and y intercepts. If you want to find the x-intercept, you're going to plug in 0 for y. And if you want to find the y-intercept, you're going to plug in 0 for x and solve. So let's go ahead and try that with these. So I'm going to do the x-intercept first. So I'm going to have 0 equals 7 minus 3x. So let's see, negative 7 is going to equal negative 3x. So x is going to equal 7/3, which isn't really that easy of a number to graph. But the coordinate for that would be 7/3, 0. There's the x-intercept. The y-intercept, we're going to plug in 0 for x. This one will be a little bit easier to solve for, so we're going to have 7 minus 3 times 0, leaving us with y is equal to 7. So this coordinate is going to be 0, 7. For time's sake, if you want to graph these, you can. You can make a t-chart with x and y values, inputs and outputs of your choosing, and go ahead and graph on the grid to your right. For this one, x squared minus 4, I'm sure that you're well versed with these parabolas that open up or down. But here, let's go ahead and solve for the x and y intercepts. So to get our x-intercept, let's plug in 0 for y. That's x squared minus 4. I'm going to go ahead and factor. So this is going to become x plus 2, x minus 2 is equal to 0. Set each part equal to 0. You're going to get 1 0 at x is equal to negative 2 and 1 at x is equal to positive 2. So the coordinates would be 2, 0 and negative 2, 0. In terms of the y-intercept, let's go ahead and solve for that. Here we're going to plug in 0 for x. And we're only going to have one y-intercept, and that's going to be at negative 4. So the coordinate for that would be 0, negative 4. All of these coordinates are on your graph, and you could use them to graph out the parabola. Okay. So some more things. The things that we're going to be analyzing about graphs are just basically symmetry. What is it symmetric to in terms of the x-axis, y-axis, and origin? Just a reminder, the x is going to go from left to right. The y, it goes up and down. Origin is going to be kind of like in a circular motion. So if you were to rotate your object around the origin, would it be symmetrical? So here we go. Here's some things that you can look for. If you have the positive point xy on your graph, and then you also have the point negative xy, it's going to be symmetric to the y-axis. So that means that you go from this side and you can flip the graph over to the other side and it's symmetrical. It's kind of like this is a mirror and the left side, it looks the same exactly as the right side. All right. The next part, if we have, if you have the point xy in your graph, and it's symmetric to the y-axis, you're also probably going to have the point x negative y. Here, when you're looking at the graph, you'll be able to flip it down over that x-axis, right? I actually want to say, if you have y to an even exponent, that's probably something to look out for. Here, if you're symmetric to the y-axis, definitely look for x to an even exponent, and it probably will be symmetric to the y-axis. Depending if it's moved from the origin or not. So the last part is if it's symmetric to the origin. And this you can kind of see if you were to take this graph and rotate the curve around, it would eventually match up with this graph down here. Coordinate-wise, if you have the point xy on one part of the graph, you're also going to have negative x, negative y on your graph. Right. X to the third is an example of something that is symmetric to the origin. Okay. On to the next page. There are ways to do tests. So to test your equation for symmetry. What you will do for all of these tests is that you're going to plug in negative values and see if it ends up becoming the same as what you started with. Just for kind of sake of going over it, though, anytime you have a negative number raised to an even exponent, it's going to end up being a positive. Anytime you have a negative value to an odd exponent, it stays negative. Okay, so if we're going to test for y-axis symmetry, what you're going to do is plug in a negative x, and if it simplifies to be the same equation, then you have symmetry to the y-axis. So let's go ahead and test. So here's our original equation. Our test, we're going to take it and plug in negative x. With this little cheat sheet over here, we have a negative number to an even exponent, so we can turn it back to positive. And this is the same as that. Since they're the same, this will have y-axis symmetry. To test for x-axis symmetry, what you're going to do is now, instead of replacing the x with a negative x, this time we're going to replace the y with a negative y and see if it turns out okay. X, let's see, minus negative y squared equals 1. Here, a negative value to an even exponent again becomes positive, so this will be x minus y squared. And that is what we started with. So this does have x-axis symmetry. The last one is origin, the test for origin. This time we're going to take both of them and switch them to negative values and see if it simplifies to be the same thing. So here's the test. So our problem becomes negative y is equal to negative x to the third. Sorry, Mrs. Grosh has just walked in. So here we go. We have negative y is equal to negative x to the third. What's going to happen is that you're going to have a negative number to the third power, which is going to stay negative. But since both sides are negative, if you divide it by negative 1, it could simplify to become what you started with. Since it simplifies to be the original thing, yes, we do have origin symmetry. Okay. So this next one, we actually just did this in example 2. So we know already that it's going to have x-axis symmetry. So what we could do to graph it is find the intercepts. So let's see. I'm going to go ahead and plug in 0, 4. How about x? Y squared is equal to 1. So you're going to get negative y squared is equal to 1. So y squared is going to equal negative 1. And then when you take the square root, that's going to yield no answer. So let's see if we have another intercept. So now this time I'm going to plug in 0 for y. So x is going to equal 1. So at least we have one coordinate, and that's going to be at 1, 0. Okay. I'm just going to make a little t-chart of values, x and y. Let's see. I'm going to let x be 1. How about 2? And how about 5? Because I know that it works. So if you plug in these, let's see. We already know 1 is 0. If you plug in 2. I think you end up getting y is equal to 1. And then when you plug in 5, I think you get y is equal to 2. So what you can do is graph those. So I'm going to have a point at 1, 0. I'm going to have another point at 2, 1. And then another point at 5, 2. 1, 2, 3, 4, 5. So here's the start of that graph. since I know, according to up to here, that it does have x-axis symmetry, I can go ahead and just flip over the other side and assume, let's see, that we're going to have points over here. So if you kind of think about it, 1, 2, 3, 4, 5. Knowing the symmetry kind of helps save you time plugging numbers into the equation, which is helpful. Okay. The last part deals with circles, kind of thrown in there randomly, which is okay. But I wrote down the equation for this circle. Just know that r is going to be the radius and the center is going to be considered to be at h and k. X and y will be any value on your circle. And we're just going to do various equations or various problems that deal with solving for different parts of the equation, depending on what you know. So this example, it says we have the point 3, 4 on our circle, and we know the center is at -1 and 2. From there, I want to find the standard form of this circle, or just the standard form of the equation. So let's kind of figure out what we know. Let's see, this is a point. So I'm going to assume since it's on the circle, that can just be representative of x and y. We do know that the center h and k is going to be at -1 and 2. All right. So here we go. They don't tell us the radius. So I'm going to go ahead and start filling things out. So I'm going to have x, which is 3, minus h, so minus -1 squared plus 4 minus k, which is 2 squared is equal to r squared. Let's see, 3 plus 1 is 4 squared makes 16. 4 minus 2 is 2 squared makes 4 equals r squared, which means that r squared is equal to 20. And you actually really don't need to solve for r because it didn't ask, oh gosh, you can't even see any of that, because you can't even, they don't ask for the radius itself. So sorry. I combined this to become 4 squared makes 16. Here, this is 4 minus 2, which is 2 squared makes 4. Add them together, you get 20. Sorry about that. So we're taking this and we're going to write the standard form of the equation. Really, it's going to look like this, except for we're not going to have x and y values. You really just need to take your r squared value and then h and k and write it into the equation format. So I'm going to have x minus -1, so x plus 1 squared plus y minus 2 squared is equal to r squared, which we just solved to be 20. And there you have it. There's your equation. Thanks for joining me.